Have you ever wondered how your social media posts can reveal your mood, or how a simple text message can shed light on your emotional state? This intriguing concept is made possible by a particular type of artificial neural network called the Feedforward Neural Network, or FNN. Picture this, a mood detection system that can analyze text-based input like your tweets, Facebook posts, or chat messages, and categorize your mood as happy, sad, angry, or neutral. Sounds like something out of a sci-fi movie, right? But it's not. It's a real-world application of FNNs. The first step in this process involves gathering a collection of text samples, each labeled with a corresponding mood. This dataset forms the basis for training our FNN. Next, the text data undergoes preprocessing. This step involves breaking down the text into words or phrases, removing irrelevant words, simplifying words to their basic form, and converting the text into numerical representations that can be understood by the FNN. Once the data is prepped and ready, the architecture of the FNN is designed. The input layer of the FNN has neurons corresponding to the numerical representations of the text data. The output layer, on the other hand, has as many neurons as there are mood categories. Now comes the exciting part, training the FNN. During this phase, the FNN learns the relationship between the input text data and the corresponding mood labels. It adjusts its internal parameters to minimize a loss function, which measures the difference between the predicted moods and the actual mood labels. The output layer of the FNN uses an activation function, often the softmax function, which converts the network's raw outputs into probability scores for each mood category. The sum of these probabilities across all categories always equals 1. The trained FNN can then classify a new text input. It processes the input through its layers and produces a probability distribution over the mood categories. The category with the highest probability is the predicted mood. The performance of the FNN is evaluated using a separate test dataset. Metrics such as accuracy, precision, recall, and the F1 score help assess how well the FNN detects moods. So imagine inputting a text message like, "I'm feeling so happy today," into this system. The FNN processes the text and predicts the mood as happy with a high probability. In essence, feed-forward neural networks provide us with a powerful tool to understand human emotions in a text-based format. They can learn patterns in text data and make accurate predictions about an individual's emotional state. This has far-reaching applications, from sentiment analysis on social media to mental health monitoring and understanding customer feedback. The potential is immense, and it's all thanks to the power of artificial neural networks.